So this chapter, which is the last chapter of chemistry, if you see, out of the 4 chapters which are given in NCERT, carbon and its compound. This is the most important chapter, not only from the marks point of view or from 10th point of view, but when you go to 11th and 12th, where you take medical branch or a non-medical branch. Just like in English, you have 2 volumes of books. Similarly, for science also, you have 2 volumes, where one volume deals with inorganic and physical chemistry, and the other part of the textbook deals with organic chemistry. So this chapter is very, very important in order to understand the organic chemistry in detail. Okay, so please don't take this chapter only from the marks point of view. Otherwise, in 11th, your basics will not get clear. Okay, so that is something which I want to tell. Now, you know that in nature, carbon exists in various forms. If I talk about clothes, if I talk about paper, plants, what is the main element that is present in all these forms? Yes, not CO2, yeah, carbon dioxide also, but element I am asking, it is carbon. Okay, like food, clothes, medicines, books, or many of the things, they contain carbon. So it becomes immense importance for us to understand, like to understand the chemistry of carbon, what all compounds it forms, and all these things. Okay, in even our in our earth crust, the percentage of carbon is 0.02%, which is in the form of carbonate, hydrogen carbonate, coal, petroleum. Our atmosphere has 0.03% of carbon. Okay, so this was about little introduction part. Now the main part arises in section 4.1, which deals about bonding in carbon, the covalent bond. In chapter number 3, you have studied a type of bond which is called as ionic bond. So what is ionic bond, and what all elements have the tendency to form this ionic bond? So the bonds that is formed by transfer of electrons from a electropositive element to a electronegative element, that is called as an ionic bond. Okay, this is the full definition. There is a transfer of electron, but it is between an electropositive element which has the capacity to donate the electron to a electronegative element which should have a capacity to or capability to accept the electron. Like in case of sodium chloride, sodium is electropositive, it can donate electrons. Chlorine is electronegative, it has the capability to accept the electron. So such a transfer of electron is known as which results in the formation of bond, and such type of bonds are known as ionic bonds. Okay, or ionic compounds. Now ionic compounds, as you can see in the highlighted text, they have high melting and boiling points. Why so? Why ionic compounds have high melting and boiling point? Because they are composed of 2 different charges. There is an electrostatic force of attraction which is existing between the 2 elements. Like Na is positive, Cl is negative. So positive and negative are attracting each other, and there is an electrostatic attraction. So you require a lot of heat to break that electrostatic interaction, and that is why the boiling point and the melting points are very, very high. Now, when we are studying about carbon chemistry, the bonds which are formed by carbon are known as covalent bonds. Okay, and how they are different from an ionic bond. So, in case of covalent bonds, these bonds are formed by sharing of electrons. See, there is a difference between transfer and sharing. When you transfer something, what happens? Say, if sodium is going to transfer its electron to chlorine, it is a full transfer taking place. Chlorine is not transferring its electron to sodium. Is it the case? Is chlorine transferring its electron to sodium? Yes. No, it is not. So it is a one-way process. I mean, sodium is completely transferring. But when you talk about sharing, whatever elements are involved in both the things, they will be equally contributing to the bond formation. So that is sharing. Sharing should be from both the side. No, it never happens that it is only from one person's side. So when in case of covalent bond, this bond is formed by sharing of electrons. We will see how. But just remember that when we say it is sharing, then what all elements are involved, they will equally contribute into the bond formation. Okay, now most of the carbon compounds are poor conductors of electricity. Why? Because they do not have electrostatic force of attraction which you find in ionic bond. For example, NaCl, KCl, they are ionic compounds. and Na is positive, Cl is negative, K is positive, Cl is negative. So there is electrostatic force of attraction. But in carbon compound, if I give you an example of CH4, which is methane, you can't say like this, okay, let us give carbon a positive charge, hydrogen a negative charge. There doesn't exist a charge like this on organic compound. Okay, there is no charge as such which exists like this in organic compound. Organic compound means compounds which are formed from carbon and hydrogen mainly. Though there are other elements also, but mainly the proportion of carbon and hydrogen is there. Okay, so if you see the melting point and boiling point of acetic acid, chloroform, ethanol, methane, these are pretty low if you compare it with ionic compounds. Okay, so these carbon compounds or as such organic compounds are poor conductors of electricity and their melting and boiling points are also low. Now, if they are saying they are poor conductors of electricity, can anyone tell me the reason why? Why they are saying that they are poor conductors of electricity? Yes. What is required for conduction of electricity? Electrons or ions, you can say. When you talk about NaCl, KCl, when you dissolve in it water, it breaks down as Na positive, Cl negative. So you have free ions. But in case of methane, if I take CH4, you dissolve it in water. First of all, it will not get dissolved because organic compounds dissolve in organic solvent like ether, petroleum, and all that thing, petrol, and all these things. So even if you dissolve it in some solvent, polar solvent, like water, it will not get dissolved, and even if it does partially, it doesn't break into its ions, like it doesn't break into C positive, then four hydrogen atoms having negative charge, not like that, because I told you in in covalent compounds there doesn't exist a charge like this. Okay, so did you get an idea about what are carbon compounds, the preliminary information? Yes. Okay, so I'll just start with the PPT. Now, what is in a carbon atom? If you see in this diagram, this is the shell structure of that carbon atom, which contains electrons, protons, and neutrons. Okay. Carbon has 6 protons, 6 neutrons. So 6 plus 6 gives you 12, and that is how you land up to the atomic mass of carbon. Okay, you write it as 12, right? And when you write the atomic number of carbon, what is it? What is the atomic number of carbon? 6. That's because it has 6 electrons. See, 2 in the innermost shell and 4 in the outermost shell. So 2 plus 4, 6. Now, what is the goal of the carbon atom when it is forming bonds? Or forget about in carbon atom. Why does any element like to form a bond? Yes. Why does any atom like to form a bond? Or why bonding state occurs? Yes, in order to get stable. Now, how can a atom become a stable species or stable entity? Yes, if you are saying that this NaCl is stable, then how you are saying it? What is your notion of stability? Very good, Samiha. The octet state or the duplet state should be complete. Yes. To go into a stable octet state, octet means 8, there should be 8 electrons in the outermost shell, or with just one shell go into duplet state, as you see in case of helium. Now, what options does the carbon atom have? Now, you know the electronic configuration of carbon, right? It is 2, 4. Whatever it is written, it is wrong. It should be 2, 4. Because in the innermost shell, the capacity is of 2 electrons, the maximum capacity, if you apply the formula of 2n square, which you have learnt in your 9th standard. Okay, so it is 2, 4. Now, you know that its octet is not complete, right? So if a carbon atom wants to form bond and if it has to gain that stability, what all ways, what all options it has? First of all, correct, yes, lose 4 electrons and enter into duplet state. If it loses its 4 electrons, then how many electrons will remain? The innermost 2. So it can achieve the duplet state, right? Correct. Or it can gain 4 electrons. So right now it is having 4 electrons, okay, in the outermost shell. If it gains 4 more, the total will be 8, and therefore it will reach octet state. Correct? Or the third way is share 4 electrons and enter into octet state, which we will see. Now let us see the option. Let us see option number 1. If it loses 4 electrons and enter into duplet state, what happens? These 4 electrons are in the second shell, as you can see in the diagram. Okay. Now remember, if you want to kick out even a single electron from an atom, you require a lot of energy, and here you are going to kick out 4 electrons, so you can just assume how much amount of energy you will require. Duplet means 2, number of electrons 2 in the outermost shell, Sandesh, and octet means it is TET. Octet means 8 electrons in the outermost shell. If an atom fulfills that then it is a stable species. Okay. So what I was telling you that is that if you want to just remove 1 electron also now from an atom, it is very difficult task, because you require a lot of energy to remove that. And here you are removing 4 electrons. So is it possible? And even if you see, it is quite close to the nucleus. So nuclear force is also existence. It is holding those 4 electrons. So is it possible for carbon to lose 4 electron and enter into the duplet state? No, it is not possible. So option number 1 is ruled out, where we are talking about losing 4 electrons and entering into the duplet state. A very high amount of energy would be needed to break them apart, so no. Let's go to option number 2, where we had seen that it can gain 4 electrons and enter into the octet state. Then what will happen? The carbon atom will have 10 electrons and 6 proton. How it is, I'll just show you. Maybe for some of them, the imagining thing will be a little bit difficult. This is the electronic configuration, right? Yes, there is specific amount of energy, and it depends upon shell to shell. Okay, so this is electronic configuration of carbon. If I add 4 more to this, what will be the final configuration? 2,8. Yes or no? Now it is stable. But if you see the structure of carbon, this is the innermost shell, this is the outermost shell. So 4 electrons were already there. Then there are two electrons, and upon it you are adding 4 more. So let's see, these 4 are the newly added electrons, which I have drawn using star. Okay, newly added. Now if you see the size of carbon atom, it is so small. Is it possible for the carbon atom to withhold 10 electrons? 2 plus 8, 10. Yes, for such a small atom, it will be very bulky and it will be very unstable formation. No, so that is also not possible. So losing 4 electrons won't help. Gaining 4 electrons also won't help to carbon. Okay. The carbon atom will have 10 electrons and 6 protons. That's too much of a difference between the electrons and protons. Difference in terms of, they are trying to say that atom is very small. It is not possible for such a small atom to hold 10 electrons. Okay. Now the third option, which is the last option remaining with carbon, is to share 4 electrons and enter into the octet state. So let us see what how can it be done. So absolutely, with sharing the electrons, that is possible. So let's see how it is. Okay. Okay, so this is basically a bond that is formed between 2 atoms by sharing of electrons. Sharing word is very important. This is called as covalent bond. I know that from the video you might have not understood in detail how the sharing has actually taken place. So what I will do is, and what I would also recommend you to do is to sit with a rough notebook, because here we are going to draw the structures and we are going to study how the sharing takes place. So it would be better if you just sit with a rough notebook, because such structures do come in your exam. Okay, so the first structure that we are going to practice is of hydrogen molecule. Okay, H2. Now what you have to do is, whenever you are drawing a Lewis dot structure, okay, we are only concerned with the number of valence electron. You should know the number of valence electron. Okay, this is the just explanation. Don't draw this in the exam. This is just for explanation. I have drawn a star in order to just make you understand that these are newly added electrons. Okay. So yes, we are going to start with the formation of hydrogen molecule, which is the simplest molecule. Now, whenever you are told to draw a Lewis dot structure, what all things you have to keep in mind? You should know the number of valence electrons, which is the number of electrons present in the outermost shell. Okay, valency and valence electrons are two different things. They are not the same. Okay, in certain cases they are same, but they are not same in all the cases. So the number of electrons which is present in the outermost shell, that is valence electron. So you should know that. Now there are two hydrogen atom, right? So I will write it like H. Okay. Now, what is the count of valence electron in case of hydrogen? 1. So I will represent it like this. Okay. This electron has one electron. This hydrogen atom has one electron. This hydrogen atom has one electron. Now, if this particular species want to gain stability, it should either complete duplet state or it should complete octet state. Now, tell me, is octet state possible? Over here, you require 8 electrons, right? Or you only have 2. So, duplet state is pretty much easier to achieve. Now this hydrogen atom has one electron. How many more it requires in order to enter into the duplet state? It requires one more. So it will take this one more electron from this hydrogen atom, and this particular hydrogen now will become stable. So this is how sharing is done. Okay. Now what about this hydrogen atom? Is it stable now? This hydrogen atom is stable because it has shared electrons. So total there are 2. Okay. Now what about this? It has one electron. It also needs one electron in order to enter into the yes, Prabha. So same way, other way round, this one electron will be captured by this hydrogen atom. Okay. Please be careful with the spherical part or with the circle part that you are drawing. Otherwise, if you make mistake in that, what students do, they do like this. 2 electron like this, then they will do like this. This is wrong. This is not a Lewis structure. From this circle or from this elliptical orbit, I don't come to know that this orbit is of which particular element. So please be careful about that. Yes. So this is a bond that is created. A bond is formed by 2 electrons. So a single bond formation takes place. Okay, I will repeat this because this is a new thing for you. What we have done, we have taken hydrogen atom. Yes, circle or elliptical orbit. That is what you can, no, it is circle or elliptical orbit only. So these are the 2 electron. Now what I have done, if I want to make this element stable, entering into the duplet state, this is how I am going to share the electron. So now this orbit which I have drawn using black color, this orbit is only of this hydrogen atom. It is not of this hydrogen atom. So be careful about the orbits. Now I want to make this hydrogen atom stable. So I'll just use a different pen so that it is clear. Now if you see the red color orbit, it encompasses these 2 electrons along with this hydrogen atom. So now both the hydrogen atoms have become stable, and between 2 electrons a bond formation has taken place. So for formation of a single bond, you require 2 electrons only. So there are 2 electrons, so a single bond can be formed, and this is how hydrogen molecule exists. H bond H. Okay, so sharing is done between these 2 hydrogen atom. This is a covalent bond. Is it clear to everyone? Now we will practice for Cl2 molecule. Yes, it can be, Mitesh. Now tell me the number of valence electron for chlorine. Each chlorine atom has hydrogen molecule forms a covalent bond. Sandesh. Yes, 7 na. So I'll draw the 7 electron. 1, 2, 3, 4, 5, 6, 7. So you can count 1, 2, 3, 4, 5, 6, 7. Okay. For this, I will just use a different color. 1, 2, 3, 4, 5, 6, 7. Now tell me, if I want to make this chlorine stable, how many more electrons I need? 7 it has already. How many more it need in order to enter into the octet state? 1. So can it share this 1 electron with the other chlorine atom like this? Now if you can count 1, 2, 3, 4, 5, 6, 7, and this one is 8. This 8th electron is lying in the elliptical orbit of this particular chlorine atom. So now it is stable. What about this other chlorine? It has 1, 2, 3, 4, 5, 6, 7. It needs one more. So can it take this electron of the other chlorine atom? Yes. So like this. Okay. Now tell me, in the center part, how many electrons you are having? In the center part, how many electrons you are having? 2. Between 2 electrons, the number of bond formed is 1. So this. So chlorine exists like this. This is your chlorine molecule and this is its Lewis dot structure. Okay. You have it in detail in your 12th organic chemistry. This is just a start of simple molecule. Yeah. Anyone is having any doubt? Maybe in the video you can't see it in this much detail as how the sharing is taking place. So I just thought that it is better to give you a magnified view of it, how the sharing actually occurs. Because in the video it is simply showing the collision. So it is very difficult to understand how using collision, how the central atoms get arranged and all that thing. Okay, now we will see the formation of N2 molecule. Now N2 molecule means 2 atoms of nitrogen. Tell me the valence electron with nitrogen. You can write the electronic configuration. It is 2, 5 for each nitrogen. Yes. So what is the valence electron? 5. Okay. Now from this number you can just guess how many shared electrons it needs. Yes. If I want to make it 8, then how many electrons I require? 2 or 3? I require 3. So I have to do an addition of 3 electron. I mean sharing of 3 electron to be more precise. So what I will do first, I will write this 5 electron. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'll just show you why I've written it like this. But just let me first explain the structure. Okay. This is 5. It needs 3 more electrons as you people said. So if I want to make this nitrogen stable, 5 it already have. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Can it take these 3 electrons with the other nitrogen atom? Yes, can it share? Okay. So I'll just do it like, so now it has become stable. 5 it already has, 6, 7, 8. So this nitrogen is now stable. What about the other nitrogen? It also has 1, 2, 3, 4, 5. It also needs 3 more electrons to become stable. Now tell me, is it stable? Yes. Now each and every nitrogen has 8 electrons in the shell, and this is how the sharing of bond takes place, right? Between 2 electron, 1 bond formation takes place. So how many bonds are you expecting over here? Yes, 3, correct. So one is this bond, second bond, third bond, and that is how we write nitrogen molecule. N, 3 bond N. And now you would have understood why I had written it like this. मैम ने ऐसा क्यों लिखा? ऐसा क्यों नहीं लिखा 1 2 3 4 5 ऐसा भी लिख सकते थे ना, राइट? वी कैन राइट लाइक दिस ऑल्सो, बट इन दिस केस you will face a lot of difficulty in sharing the electron. This is pretty much easier and clean to understand. Okay, so you know now it has 5 electrons, so it needs 3 more electron. So somewhere in your mind this process should go on, that 3 bond formation might have taken place. So you can draw the 3 electrons in the center, because these 3 electrons will participate in sharing, and remaining 2 you can arrange it anywhere. You can arrange it in sideways, you can arrange it at the top, you can arrange it at the bottom. Okay, so that you can show the sharing. If you draw it in this way, first of all, this is not a good way to draw. Not even in higher classes this won't be accepted and this won't be recommended, so don't go using this way. Yes, so the shared electrons you have to draw it in the front, and the remaining electrons which are not participating then. No, you can skip that. I have just drawn it in order to make you understand that the bond formation between 2 electron, one bond formation takes place. So you can skip that. Can't that 2 electron be shared? This 2 you are talking, Mitesh? This 2? No, these are not participating. Why it will get shared when it has already achieved the octet? Now it is stable ना, so now it doesn't want to gain more stability. खुश है वो, जितना उसको stability मिलेगी, it is much and more happier. So it won't disturb its state. Okay, so is this clear about the covalent bond? It is formed by sharing of electrons. We will continue with the second period. For now, you can take a break and return back.
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.